Thank you for joining another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and in this chapter we are going to discuss exponents. We'll discuss how you combine exponents by multiplying like bases, the product rule, by dividing like bases, the quotient rule, and we'll also discuss the power of a product rule as well as the power of a quotient rule. Should you have any follow-up questions, feel free to leave them in the comment section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Let's kick things off by discussing monomials. A monomial is a number, 1, 2, 3, 4, 5, a variable, a, b, c, x, y, z, or a product of a number and one or more variables in which the exponents are all whole numbers. Now this last part, a product of a number and one or more variables. So these three terms would be examples of that. Negative 2x, our number variable, 5xy squared, our number and multiple variables, similar to 7x to the 4th, y to the 9th. And in all three of these different terms, the exponents are whole numbers. 9, 4, 7 to a power of 1 is 7, 5 to the power of 1, x to a power of 1, y to a power of 2, negative 2 to a power of 1, x to a power of 1. When the exponent is not shown, that means it's to a power of 1, it's just itself. An exponent that's a fraction would be a radical. So we won't be dealing with those terms. If you'd like to discuss exponents that are fractions, check out our radicals chapters. But let's now dive deeper into what the exponent is. The exponent, which in this case is b, is the number or variable placed at the upper right corner of the base, which here is x. So you have your number or variable that is being raised to a power, or to an exponent b, and then the number in front of it that you're multiplying it times is the coefficient. So let's dive deeper into this. The exponent b represents the number of times you would multiply the base, x, times itself. So you multiply the base times itself, b number of times, and then you take that and you multiply it times the coefficient a. So what would this look like with a few numbers involved? Let's say our base was the variable x, our coefficient is the number 2, and our exponent is 3. That means you're going to multiply the base x times itself 3 times, x times x times x, and then you multiply that times 2 times 2. So 2x cubed expanded is equal to 2 times x times x times x. If the base is a number, 7, you multiply 7 times itself 3 times, 7 times 7 times 7, and you take that product and multiply it times the coefficient 2, and that would have a total value of 686. But this is just an example of how the exponent relates to our base and how those relate to our coefficient. Let's now take a look at a different power, the power of 1. Any base to a power of 1 is equal to itself. 3 multiplied once is just 3. Right? 3 to a power of 2 would be 3 times 3. There'd be 2 of them. So if the exponent's just 1, it's just the base. 3 to a power of 1 is equal to 3. 5x to a power of 1 is equal to 5x. In this case, this 1 is only being applied to the x. Here, 5x to the 1 is equal to 5x. In this case, the 1 is being applied to both. We'll talk a little bit more about this in a second, how the exponent outside of the parentheses relates to each term inside of the parentheses. But let's take a look at the power of 0. Any base to a power of 0 is equal to positive 1. Apply the exponent to the number immediately to the left of it, or to the term inside of a pair of parentheses. So for example, if you just have a number being raised to a power of 0, that's equal to 1. The 0 is immediately to the right of it. And in this example, since this entire term, this monomial, is inside a pair of parentheses, this power of 0 is applied to the entire thing. So it's essentially the same as this. 5 to a power of 0. This is like x to a power of 0. It's just a singular term being applied to this exponent, just like this. So it's also equal to 1. The power of 1, the number remains itself. The power of 0, the term is equal to 1. Now, if you have a negative, and the negative is not inside the pair of parentheses, the exponent is only applied to the term. So negative x to a power of 0 is equal to negative times whatever the result of x to the 0 is, which is 1. So that would give us negative 1. Again, the exponent is only applied to the number immediately to the left of it if there's no parentheses. So here, the 0 applies to the x. So this becomes 1. So you get 5 times 1, which is equal to 5. So throughout this chapter, you want to be very careful as to what term or which terms the exponent that you see is being applied to. So be very careful as you are multiplying variables, simplifying expressions, and so forth. Let's now take a look at another example involving the negative sign. The negative sign in front of the base is only affected by the exponent if it is inside a pair of parentheses with the base. If not, the exponent only affects the base itself. So in this example here, we have negative 2 to a power of 4. The negative is a part of the term 2, so the 4 applies to this entire thing. So you multiply this entire thing times itself 4 times. So we get negative 2 times negative 2, that's twice, times negative 2, 3 times negative 2, that's 4. And that would equal positive 16. If the negative is not inside a pair of parentheses with the number 2, then this exponent 4 only applies to the 2. So the negative stays on the outside as you do 2 to the 4th, 2, 2, 2, and 2. So negative 1 times 16 would give us negative 16. So pay close attention to the negative signs, the parentheses throughout these expressions. It drastically affects the values of these expressions and terms. Let's now do a few practice questions. Evaluate each for x is equal to 5. Question number 1, 3x to the 4th. Question number 2, negative 4x to the 3rd. Question number 3, negative 6x squared. And question number 4, negative 3x squared, y to the 0. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given the monomial 3x to the 4th. Here we see our exponent is the number 4, and it's being applied to the base of x. So since we're evaluating for x is equal to 5, step 1, plug 5 in for x. So where we see x, we plug in 5. So we get 3 times 5 to the 4th. Step 2, replace the exponent 4 by multiplying 5 a total of 4 times. So that's equal to this, 5 times 5 times 5 times 5. And we're multiplying that times the coefficient of 3, which would give us 1,875. Question number 2. We were given the monomial negative 4x to the 3rd. So we want to plug in step 1, 5 for x. So that gives us negative 4 times 5 to the 3rd. Step 2, we want to replace the exponent 3 by multiplying 5, the base, a total of 3 times. So x cubed, when x is equal to 5, is equal to 5 cubed, which is 5 times 5 times 5. Multiply that times the coefficient of negative 4, and that would give you negative 500. Question number 3. We are given the monomial negative 6x squared. In this case, we have negative 6x enclosed in a pair of parentheses. That means step 1, we still plug in 5 for x. That gives us negative 6 times 5. And since negative 6x is inside the pair of parentheses, this negative 30 is what you are multiplying a total of 2 times, step 2. So you get negative 30 times negative 30, which gives you an answer of 900. And question number 4, we are given the term negative 3x squared y to a power of 0. Step 1, plug 5 in for x. That gives us negative 3 times 5 squared. And step 2, we want to replace y to the 0 with positive 1. So that gives us this, negative 3 5 squared times 1. And 5 squared means that we're multiplying 5 a total of 2 times. So this equals negative 3 times 5 times 5 times 1, which equals negative 75. So those are a few examples about how you would evaluate the value of a term that has multiple variables if you're plugging in a value for one or some of those variables, and how the negative sign is affected by the presence of parentheses. Now, before we move on to discuss the product rule, let's discuss negative exponents. A negative exponent in the numerator becomes positive in the denominator, and a negative exponent in the denominator becomes positive in the numerator. So this example, 6 to a power of negative 2, this is technically in the numerator. It's being divided by 1. So to make this exponent positive, you switch this term and put it in the denominator. That's how we go from negative 2 to positive 2. So 6 to a power of negative 2 is equal to 1 over 6 squared, which is equal to 1 over 36. Let's say you had 2 times x to a power of negative 3. This exponent is only being applied to the x, since this term is not inside a pair of parentheses. So this 2 remains in the numerator, and this x moves to the denominator, and we can switch the exponent from negative 3 to positive 3. One more example of this, x to a power of negative 2 becomes x squared when we switch it from numerator to denominator, and y to the negative 4 in the denominator becomes y to positive 4 in the numerator. So when you have a negative exponent, you move that term to the opposite side of the fraction line, and then you make the exponent positive. Let's have you do a few practice questions. Rearrange each so all exponents are positive. Question number 1, 4 to the negative 3. Question number 2, 5x to the negative 2. And question number 3, x to the negative 3, y to the 4th, z to the negative 2, divided by v to the negative 5th times w cubed. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we're given 4 to the negative 3. That's the same as dividing it by 1. Anything divided by 1 is just itself. So this makes it a bit easier to see that step number 1, move the term with a negative exponent to the opposite side of the fraction line. So we move 4 to the negative 3 from the numerator to the denominator. And that allows us to step 2, make the exponent positive. 1 over 4 cubed is equal to 1 over 64. So that is the answer to question number 1, 1 over 64. Question number 2, we are given 5 times x to the negative 2. That is the same as 5x to the negative 2 over 1. Step 1, move the term with a negative exponent, which in this case is just the x, to the opposite side of the fraction line. So we move that to the denominator, and we make the exponent negative 2 positive, giving us an answer of 5 over x squared. Then question number 3, we have multiple terms in the numerator and the denominator. So we'll first work with the numerator. Step 1, move each term with a negative exponent to the opposite side of the fraction line. And then we make the exponents positive. Step 2, so in our numerator, the terms with negative exponents are x and z. So we move x and z to the opposite side of the fraction line and make those exponents positive. And then we have in the denominator v with a negative exponent of negative 5. So we move that up to the numerator. And that gives us a final answer of v to the 5th times y to the 4th divided by w to a power of 3, x to a power of 3, z to a power of 2. Let's now discuss the product rule. To multiply like bases with exponents, keep the base and add the exponents together. So x is our base in this term and x is our base in this term. So we can multiply these terms by adding their respective exponents. So x to a power of m times x to a power of n would allow us to simplify it to just one base instead of two. And we do that by adding the exponents together, m plus n. What would this look like with a few values plugged in? 5 to a power of 2 times 5 to a power of 6 is equal to 5 to the power of 2 plus 6, our two exponents. 2 plus 6 would give us 8. If we had 7 to a power of negative 3 times 7 to a power of 5, even though this exponent is negative, since we're multiplying like bases, we still want to add the exponents. So negative 3 plus 5 would give us positive 2. So in this case, even though we have a negative exponent, you do not have to move it to the opposite side of the fraction line. You can still multiply these bases by adding the exponents when the exponents are negative. Negative or positive doesn't affect what you do as a result. So let's walk through an example like this where we have coefficients as well. 4x squared y cubed times negative 2x y to the 4th times z. Step 1, multiply the coefficients. So we multiply 4 times negative 2 to give us negative 8. We then, step 2, multiply the like terms by adding the exponents. So that means regardless of what variables are inside each parentheses, when you're multiplying them, for the variables, you only multiply the variables that are the same by adding their exponents. So x and x are like terms. So x squared times x is equal to x to the 2 plus 1, 2, and when it's not shown, that's a power of 1. So that gives us x to the 3rd. Then we have y to a power of 3 times y to a power of 4, which gives us y to a power of 3 plus 4, which is 7. And now in this monomial, we don't have z, but in this one we do. So that just leaves us with z to a power of 1, which is just z. So that leaves us with the answer, negative 8 times x to the 3rd, y to the 7th, z. Now let's have you do a few practice questions. Find the product Question number 1, a to the negative 9 times a to the 4th. Question number 2, x to the 4th y squared times x to the negative 3 y z to the 2nd. And question number 3, negative 5 x to the 6th y to the negative 2 times 2 x to the negative 3 y to the 7th. Pause the video, answer this question, and then press play when you are ready to begin. Question number 1, step 1, multiply the like terms, a, by adding the exponents, negative 9 and positive 4. Negative 9 plus 4 is equal to negative 5. And since we have a negative exponent, we want to move this term from the numerator to the denominator. So step 2, move the term with the negative exponent to the opposite side of the fraction line, and then make the exponent positive, step 3. So the final answer becomes 1 over a to the 5th. Add the exponents, negative exponent, so you move that to the opposite side. Question number 2, we add x to the 4th y squared times x to the negative 3 y z squared. Step 1, multiply the like terms by adding the exponents. So we'll multiply the x's, we'll multiply the y's, and then we only have one z. So the x's, x to the 4th times x to the negative 3 is equal to x to the 4 minus 3, which is 1. So we just wind up with x. We multiply our y's, y to a power of 2 times y to a power of 1 is equal to y to a power of 2 plus 1, which is 3. We do not have a z term in this expression, but we have one over here. So we just bring this down. Since we're multiplying all of these terms, we're multiplying this times the product here. So our final answer is x times y to the 3rd times z squared. Question number 3, negative 5 x to the 6th y to the negative 2 times 2 x to the negative 3 y to the 7th. Step 1, multiply the coefficients. Negative 5 times 2 is equal to negative 10. Step 2, multiply the like terms by adding the exponents. So we multiply our x's, and then we'll multiply our y's. So for our x's, x to the 6th times x to the negative 3 is equal to x to the 6 minus 3. Remember, positive 6 plus a negative is the same as just subtracting it. So x to the 6 minus 3 is equal to the x to the 3. And then lastly, the y to a negative 2 times y to the 7th is equal to y to the negative 2 plus 7, which gives us our final answer of negative 10 x to the 3rd times y to the 5th. So that is how we use the product rule when we want to multiply two like bases. But when you want to divide two like bases, you want to use the quotient rule. To divide like bases with exponents, keep the base and subtract the exponent in the denominator from the exponent in the numerator. So when I tell you to subtract the exponents, this is what I mean. M minus n, you're finding the difference by subtracting the exponent in the denominator from the exponent in the numerator. So if we had x to the 5th divided by x to the 3rd, we keep the base, x, and we subtract the exponents, 5 minus 3, which gives us 2. If the exponent in the denominator were negative, that does not change the process. You are still subtracting the negative. So x to the 5th divided by x to the negative 3rd is equal to x to the 5th minus negative 3, When you subtract a negative, it's the same as adding them. So 5 plus 3 equals 8. Let's have a look at an example with coefficients and multiple variables. What you would do, step 1, divide the coefficients. So these are like terms, if you will. 20 divided by 4 is equal to 5. Then step 2, you divide the like terms by subtracting the exponents. So you divide the x term by an x term only. X to the 9th divided by x to the 3rd is equal to x to the 9 minus 3, which is 6. You divide your y's. Y to the 7th divided by y to the 5th is equal to y to the 7th minus 5, which is 2. And then you have z to the 3rd and no z in the denominator. So that just leaves you with z to the 3rd in the numerator. So that gives you a final answer of 5 times x to the 6th times y squared times z cubed. So to utilize the quotient rule, when you are dividing monomials, you divide the coefficients and then you divide only the like terms. Let's have you do a few practice questions. Find the quotient. Question number 1, x to the 4th, y to the 10th, divided by x to the 3rd, y to the 12th. Question number 2, 12, x to the 8th, y to the 4th, z to the negative 2, divided by 4, x to the negative 2, y, z to the negative 4th. Question number 3, 20, x to the 6th, y to the negative 1 times z, divided by 5, y squared, x, z cubed. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, divide the like terms by subtracting the exponents. So you are going to divide x by x. So we have x to the 4th divided by x to the 3rd. When we subtract the 3 from the 4, we get x to the 4 minus 3, which is 1. So that's just x. You divide your y term by the other y term. Y to the 10th divided by y to the 12th is equal to y to the 10th minus 12, which is negative 2. So we have a negative exponent, so we'd like to make that positive. So step 2, move each term with the negative exponent to the opposite side of the fraction line. And then step 3, make the exponent positive. So we move the y to the negative 2 to the denominator, and that gives us a final answer of x over y squared. Question number 2, step 1, divide the coefficients. So 12 divided by 4 equals 3. Step 2, divide the like terms by subtracting the exponents. So you're going to divide your x by the x term, your y by the y, and the z by the z. So starting with the x's, x to the 8th divided by x to the negative 2. You subtract negative 2 from 8. So x to the 8th minus negative 2 is 8 plus 2, which is 10. Our y terms, y to the 4th divided by y. Since it's just y, the exponent is 1. So we get y to the 4 minus 1, which is 3. Then lastly, our z terms. Z to the negative 2 divided by z to the negative 4 is z to the negative 2 minus negative 4, which is plus 4. So we get positive 2 for z, giving us a final answer of 3x to the 10th, y to the 3rd, z squared for question number 2. Then lastly, question number 3. We were given 20 x to the 6th, y to the negative 1z over 5y squared x z cubed. You want to organize your variables in the same order, so when you're dividing the like terms, it's a bit easier. When you're multiplying these terms, it does not matter what order they are in. So if you're given a term in the denominator where the variables are not in the same order, just reorganize them so that they line up with the top. Whole number over whole number, x over x, y over y, z over z, and all of our exponents are the same. And now you can proceed. So step 1, divide the coefficients. 20 divided by 5 is equal to 4. Step 2, divide the like terms by subtracting the exponents. X to the 6 divided by x is equal to x to the 6 minus 1, which is 5. Y to the negative 1 divided by y squared is equal to y to the negative 1 minus 2, which gives you negative 3. And then z divided by z cubed is z to the 1 minus 3, which is negative 2. So we have 4x to the 5th, y to the negative 3, z to the negative 2. So step 3, move each term with a negative exponent to the opposite side of the fraction line. And then step 4, make the exponents positive. So we're going to move our y and z terms from the numerator to the denominator and make their exponents positive, giving us a final answer of 4x to the 5th over y cubed z squared. So before we discuss the power of a product rule, we'll first take a look at the power of a power. To raise a term with an exponent to a power, multiply the exponents. So if you had x to a power of m to a power of n, you're going to multiply this exponent and this exponent. So this would give you x to a power of m times n. Let's say you had x cubed and then you wanted to square it. That's the same as multiplying the 2 and the 3 to give you x to the 6th. So when you have a term with an exponent inside a pair of parentheses and you're raising it to another exponent, you multiply the exponents. The product rule, when you're multiplying like bases, you add the exponents. We are not multiplying like bases here. We are raising this term to another power. So we're multiplying them. If this exponent were negative, so let's say we had x to the negative 2 times 3, that doesn't change the process. You still multiply these exponents. So you get x to the negative 2 times 3, which is x to the negative 6. Same thing. You multiply the exponents. So this is the power of a power. The power of a product is similar. That is when you have a product inside the parentheses and an exponent on the outside. You distribute that exponent to each term inside. So the v gets distributed to the x and to the y. So we multiply it times this exponent of m and this exponent of n to give us x to the mv times y to the nv. Okay, so if there are multiple terms inside the pair of parentheses, like we have here, then distribute the exponent to all of the terms inside of the parentheses. So let's say we had x squared y cubed raised to a power of 4. We distribute this 4 to the exponent 2, and we distribute the 4 to the exponent of 3. So we're distributing it to both terms, x and y. So 2 times 4 gives us x to the 2 times 4, which is 8. And y cubed to a power of 4. So that gives us y to the 3 times 4, which is y to the 12th. So that is how the power of a product rule works. Let's take a look if we had a coefficient. Let's say we had the monomial 2x cubed y to the 4th to a power of 5. Step 1, distribute the exponent 5 to the coefficient. So that gives us 2 to a power of 5, which is equal to 32. Step 2, distribute the exponent 5 to each variable by multiplying the exponents. So you distribute the 5 to the x. So since we have x cubed, that gives us x to the 3 times 5, which is x to the 15th. And you distribute the exponent 5 to the y variable. Y already has an exponent of 4, so that gives us y to the 4 times 5, which is y to the 20th. So that gives us 32, x to the 15th, y to the 20th. Let's have you do a few practice questions. Evaluate question number 1, 4x squared to a power of 3. Question number 2, 3x to the 5th y squared to a power of 4. And question number 3, negative 5x to the 3rd y to the 6th z to a power of 2. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Step 1, distribute the exponent 3 to the coefficient 4. 4 to a power of 3 is equal to 64. Step 2, distribute the exponent 3 to each variable by multiplying the exponents. So in this case, we only have one variable x, and it has a power of 2. So we distribute this 3 to this term by multiplying the 2 and 3. X to a power of 2 times 3 is equal to x to a power of 6. So the answer to question number 1 is 64, x to a power of 6. Question number 2. Step 1, distribute the exponent 4 to the coefficient 3. 3 to a power of 4 is equal to 81. Step 2, distribute the exponent 4 to each variable by multiplying the exponents. So we distribute the 4 to our x term, and that gives us x to a power of 5 times 4, which equals 20. And we distribute the 4 to our y term, and we get y to a power of 2 times 4, which is equal to 8. So the answer to question number 2 is 81, x to the 20th, y to the 8th. And question number 3, since this negative sign is on the outside of the parentheses, we are going to distribute this 2 to the terms inside the parentheses and leave this negative sign on the outside. So step 1, distribute the exponent 2 to the coefficient 5. 5 squared is 25. We still have our negative. So instead of having negative 5 squared and getting positive 25, we wind up with negative times that. So I can remove the parentheses now since we're going to get negative 1 times this whole term. So now we can do step 2, distribute the exponent 2 to each variable, x, y, and z, by multiplying the exponents. So x to a power of 3 to a power of 2 is equal to x to a power of 3 times 2, which is x to a power of 6. Our y term, y to a power of 6 to a power of 2, is equal to y to a power of 6 times 2, which is y to the 12th. Then z to a power of 1 to a power of 2 is equal to z to a power of 1 times 2, which is 2. So the answer to question number 3 is negative 25, x to the 6th, y to the 12th, z squared. So that is how you would utilize the power of a product rule. Let's now discuss the power of a quotient rule. To raise a fraction to an exponent, distribute the exponent to the term or terms in the numerator and the denominator. So if we add x to a power of m divided by y to a power of n, and we raise this entire fraction to a power of p, The power of a quotient rule is telling us to multiply this number times this exponent and this exponent. So in the numerator, we get x to the m times p. And in the denominator, we get y to a power of n times p. So this is the power of a quotient rule. Let's take a look with a few numbers installed. So x to a power of 8 squared would be x to a power of 8 times 2. 8 times 2 is 16. Y to the 4th is in the denominator. We multiply this exponent of 4 times 2, just like we did in the numerator. So that gives us y to a power of 4 times 2, which is equal to y to a power of 8. So this is how you would utilize the power of a quotient rule. Distribute this exponent to all of the exponents inside the parentheses, both in the numerator and the denominator. Let's say we had an example with coefficients. Step 1, distribute the exponent on the outside 2 to the coefficients in the numerator and the denominator. So in this example, we have 5x cubed divided by 4y, and we square the entire thing. So step 1, distribute this exponent to the 5 in the numerator and the 4 in the denominator. 5 squared is 25. 4 squared is 16. Then step 2, distribute the exponent 2 to each variable by multiplying the exponents. So x to a power of 3 to a power of 2 is equal to x to a power of 3 times 2, which is x to the 6th. And we distribute the 2 to the y in the denominator as well. Since it's just y, that means the exponent is 1. So y to a power of 1 times 2 is y squared. So our final answer would be 25x to a power of 6 over 16y squared. Distribute the exponent on the outside to both coefficients and to all of the variables by multiplying this exponent times each of the exponents inside. Let's have you do a few practice questions. Evaluate question number 1, x squared divided by y cubed to a power of 5. Question number 2, 2x over y to the 4th to a power of 3. And question number 3, 6x cubed y to the 4th divided by 5x to the 4th y cubed raised to a power of 2. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, distribute the exponent 5 to each variable by multiplying the exponents. So we have x squared in the numerator. So we multiply the exponents 2 and 5. And in the denominator, we have y cubed. So we multiply this exponent 3 times the exponent 5 as well. This would give us x to the 10th over y to the 15th. Question number 2. Step 1, distribute the exponent 3 to the coefficient in the numerator 2. 2 to a power of 3 is equal to 8. Now we want to distribute this exponent, step 2, to each variable by multiplying the exponents. So this exponent 3 gets distributed to x to a power of 1, which gives us x to a power of 1 times 3, which is x cubed. Y to a power of 4 raised to a power of 3 gives us y to a power of 4 times 3, which is y to a power of 12 in the denominator, giving us a final answer of 8x cubed divided by y to the 12th for question number 2. Then question number 3, step 1, distribute the exponent 2 to the coefficients in the numerator and the denominator, 6 and 5. So 6 squared would give us 36, and 5 squared would give us 25. Step 2, distribute the exponent 2 to each variable by multiplying the exponents. So we distribute the 2 to our x's. X to a power of 3 to a power of 2 gives us x to a power of 6 in the numerator. And in the denominator, x to a power of 4 to a power of 2 is equal to x to a power of 4 times 2, which is 8. X to the 6, x to the 8th. Then we distribute this exponent of 2 to the y terms. In the numerator, we have y to a power of 4 to a power of 2, which is equal to y to a power of 4 times 2. So we get y to a power of 8 in the numerator. And in the denominator, y to a power of 3 to 2 gives us y to a power of 3 times 2, which is y to the 6th. So after step 2, we wind up with 36 x to a power of 6, y to a power of 8, divided by 25 x to the 8th, y to the 6th. And now we use the quotient rule to simplify our x and y terms. So step 3, divide the like terms by subtracting the exponents. We cannot simplify 36 divided by 25 any further, so we just leave that as our coefficient. We divide our x terms. X to a power of 6 divided by x to a power of 8 is equal to x to a power of 6 minus 8, which is negative 2. And then our y terms, y to a power of 8 divided by y to a power of 6 is equal to y to a power of 8 minus 6, which is positive 2. So now, step 4, move each term with a negative exponent to the opposite side of the fraction line. And step 5, make the exponent positive. So in this case, the only term that has a negative exponent is x. So we move x to a negative 2 to the denominator, and we make it positive, so we get x squared. So that leaves us with the final answer of 36y squared divided by 25x squared. And now to wrap things up, if more than one term has an exponent, distribute the exponents to the appropriate terms and then multiply the resulting terms. So if you had xy to a power of m times vw to a power of z, you first distribute the exponent to its respective term, and then you multiply the resulting terms. So what would this look like? Let's say you had xy to a power of 2 times x squared y z to a power of negative 3. You do want to multiply your like terms x and y, but you first need to distribute these exponents. So 2 times this exponent of 1 gives us x squared. Negative 3 times 2 gives us x to the negative 6th. So after you distribute the initial exponents, now you can multiply these terms. Same thing with the y. 2 times the power of 1 is 2, so we get y squared. Negative 3 times the power of 1 is negative 3. Z to a power of negative 3 is negative 3. So after you distribute the initial exponents, then you can multiply the resulting terms. You may also encounter a situation in which you are dividing two terms that have unique exponents. If the numerator and the denominator have unique exponents, then distribute the exponents before dividing the like terms. So in this case, we have x squared y cubed to a power of 4 divided by x to the 5th y to the 6th squared. So before you can divide your x's, you first need to distribute this 4 to this exponent 2. That would give you x to a power of 2 times 4, which is x to the 8th. Same thing with the y. Y to the 3rd to a power of 4. 3 times 4 would give you 12. Same thing in the denominator. Distribute this 2 to this 5 and this 6. So we get x to the 5 times 2, which is x to the 10th. Y to the 6 times 2 gives you y to the 12th. And now that you've distributed those exponents, now you can divide the like terms in this step. Okay, so let's wrap up this chapter by completing these practice questions. Question number 1, 3x to the negative 5, y squared to a power of 0, divided by 4x to the negative 3, y squared to a power of negative 2. Question number 2, 2x to the negative 3, y to the 4th to a power of negative 2 times 3x squared, y to the negative 3 to a power of 4. And question number 3, negative 4x squared, y to the negative 3 to a power of 2 times 2x to a negative 4, y to the negative 2 to a power of 3. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, replace the numerator with positive 1. So since we have this entire monomial inside a pair of parentheses, this exponent of 0 is being applied to the entire thing. It's the same as having 3 to a power of 0, which is 1, times x to the negative 5 times 0, which is x to a power of 0, which is 1, times y squared to a power of 0, which is y to a power of 0. So you get 1 times 1 times 1, which is 1. Then you deal with the denominator separately, two different terms with two different exponents. So this one applies to the numerator, this one applies to the denominator. Step 2, distribute the exponent negative 2 to the coefficient 4. So that gives us 4 to the negative 2. So we'll leave that there until we make this positive. Step 3, distribute the exponent negative 2 to each variable by multiplying the exponents. So x to a power of negative 3 to a power of negative 2 is equal to x to a power of negative 3 times negative 2, which is positive 6. And then y to a power of 2 to a power of negative 2 is y to a power of 2 times negative 2, which is negative 4. So we wind up with 1 over 4 to the negative 2, x to the 6, y to the negative 4. So now we've simplified our expression, but we have negative exponents. So our last steps 4 and 5, we move each term with a negative exponent to the opposite side of the fraction line and make the exponents positive. So that moves 4 to the negative 2 to the numerator to give us 4 squared, and y to the negative 4 up to give us y to the 4th. 4 squared is 16. So the final answer to question number 1 is 16 y to the 4th divided by x to the 6th. Question number 2. Step 1, distribute the exponent negative 2 to the coefficient 2. So that gives us 2 to the negative 2. Since that's negative, we'll leave that there until we make it positive. Step 2, distribute the exponent negative 2 to each variable by multiplying the exponents. That's each variable inside this pair of parentheses, not all of them. So x to the negative 3 to the negative 2 is equal to x to the negative 3 times negative 2, which is x to the 6th. And we have y to the 4th to a power of negative 2, which gives us y to a power of 4 times negative 2, which is y to the negative 8. And now we distribute this exponent 4 to each term inside of the parentheses here. So step 3, distribute the exponent 4 to the coefficient 3, giving you 3 to a power of 4, which is 81. Then step 4, distribute the exponent 4 to each variable, x and y, by multiplying the exponents. X squared to a power of 4 is x to a power of 2 times 4, which gives us 8. And y to a power of negative 3 to a power of 4 is equal to y to a power of negative 3 times 4, which is y to the negative 12. And now step 5, move each term with the negative exponent to the opposite side of the fraction line. We want to get this exponent positive so we can evaluate this term, so we can combine the coefficients, just like we'll be combining our like terms. So let's move the negative exponents to the opposite side of the fraction line. So 2 to the negative 2 becomes 2 to the positive 2 when we move it from the numerator to the denominator. Y to a power of negative 8 is negative in the numerator, but becomes positive in the denominator, positive 8 instead of negative 8. And this y is the other term with the negative exponent, negative 12. So we move that to the denominator as well. 2 squared becomes 4. And now the last step, step 7, multiply the like terms by adding the exponents. So x to the 6th times x to the 8th is equal to x to the 6 plus 8, which will give us x to the 14th in the numerator. And in the denominator, y to the 8th times y to the 12th is equal to y to the 8th plus 12, which is y to the 20th. And that gives us a final answer of 81x to the 14th over 4y to the 20th. And now question number 3. Step 1, distribute the exponent 2 to the coefficient 4. This negative sign is on the outside of the parentheses, so we'll keep it on the outside as we distribute this exponent to each of these terms. So we get 4 squared, which gives us 16. Step 2, distribute the exponent 2 to each variable by multiplying the exponents. X to a power of 2 to a power of 2 is equal to x to a power of 2 times 2, which is x to the 4th. Y to a power of negative 3 to a power of 2 is equal to y to a power of negative 3 times 2, which gives you y to the negative 6. And now we deal with this monomial with this exponent 3. So step 3, distribute the exponent 3 to the coefficient 2. 2 cubed gives us 8. Step 4, distribute the exponent 3 to each variable by multiplying the exponents. X to a power of negative 4 to a power of 3 is equal to x to a power of negative 4 times 3, which is x to the negative 12. And then y to a power of negative 2 to a power of 3 is equal to y to a power of negative 2 times 3, which is y to the negative 6. So now we can multiply these two terms. So step 5, multiply the coefficients. Negative 16 times 8 gives us negative 128. And now step 6, we multiply the like terms by adding the exponents. So we'll multiply our x's and then we'll multiply our y's. X to the 4th times x to the negative 12th is x to the 4th minus 12, which is x to the negative 8. Y to the negative 6 times y to the negative 6 is y to the negative 6 minus 6, which is y to the negative 12th. And now step 7, move each term with a negative exponent to the opposite side of the fraction line. And step 8, make the exponents positive. So our x term and y term both have negative exponents, negative 8 and negative 12 respectively. So we move these two variables to the denominator and make their exponents positive, giving us a final answer of negative 128 over x to the 8th times y to the 12th. And that wraps up this chapter on exponents. If you have any follow-up questions, feel free to leave them in the comment section, or you can contact a tutor in your area by visiting bookandtable.com or by downloading our app on the App Store. Peace.